In this next example, we're asked without actually solving the equation to list all possible solutions that would be rejected if they appeared as potential solutions, and then give the domain using set builder notation. So if we want to know what are all the numbers that we are allowed to put in, or what numbers would be rejected from the domain, all you have to do is take the bottom and set it equal to 0 and solve for x. So notice here in this particular equation we have two different factors for the denominator. We have x minus 6 and we have x plus 2. So all we need to do is take them and solve for x, and we can do that with mental math. X would be 6 and negative 2. And so what that is saying is those are the only two numbers that you would not be allowed to plug in, and the reason for that is because those two numbers would make the bottom undefined. So to write that in set builder notation form is basically saying that I can plug in any number for x, all real numbers except negative 2 and 6, and just simply put a comma between the two. So it's still the same. X is such that x can be any real number, but it cannot be negative 2 or 6. Why? Because those two values are the values. If you were to plug it in, it would make the bottom undefined. And as I said before, it doesn't matter if it makes one part or two parts undefined. As long as any part of it has a 0 in the bottom, then that means that is a number that is restricted from the domain. And if you had those numbers as your solutions, you would have to reject them or throw them out. In other words, let's say I go through the motions of solving this equation, and when I'm done solving it, x equals negative 2 or 6. I would have to throw those solutions out. I cannot keep them because those are the two numbers that would make the bottom undefined. And there you have it, determining the domain of a rational equation.